Sector area and arc length. Our objective is to find the area of sectors and find arc lengths. Well, who uses this? Farmers use irrigation radii to calculate areas of sectors. Let's look at a formula. A sector of a circle is a region bounded by two radii of the circle and their intercepted arc. Basically, it's a piece of a circle. So, we're going to use our formula for the area of a circle, which is pi r squared, and then this m divided by 360 is that piece of the area. So, let's try a couple examples. We'll do the first one together, and then you guys can try the next one on your own. Okay, so we know that our formula is pi times our radius, which in this case is 3, so pi times 3 squared, and we're going to multiply the area by the piece that we're looking for, so 80 divided by 360. So 80 divided by 360 times 3 squared will give you 2, and don't forget your pi, so 2 pi, which is about 6.28, and that would be inches squared. Take a moment and try this next one on your own. Now that you've had a moment to try this next one on your own, let's try it together. So we have pi times our radius, so 6 squared, times 120 divided by 360. 120 divided by 360 times 6 squared will give you 12 pi, which is about 37.7. And we have centimeters, so centimeters squared. Let's try a real-world application. A circular plot with a 720-foot diameter is watered by a spray irrigation system. To the nearest square foot, what is the area that is watered as the sprinkler rotates through an angle of 50 degrees? Well, let's take what we know and just plug it into our formula. We know that our m is going to be the 50 degrees, and our radius is going to be half of 720. And half of 720 is 360. So we can plug those in. When we do so, we have 50 divided by 360 times 360 squared times pi. And when we enter all that in, we end up with 56,549 feet squared. Let's look at another formula. A segment of a circle is a region bounded by an arc and its chord. Basically, it's the little shaded region. To find that, you're going to find the area of your sector, which is what you've just been doing, and you're going to subtract the area of the triangle, something that we know how to do from a previous section. When you take your area of your sector, subtract the area of your triangle, you're left with the area of a segment. Let's try this first one together. Step 1. Find the area of sector ABC. So we have pi times our radius, so 12 squared, times the piece that we're looking for, so 60 divided by 360. And when we do so, we end up with 24 pi, and that would be inches squared. Alright, well that's step 1. Step 2. We need to find the area of the triangle. The area of the triangle in this case is a little bit trickier than if they were nice and gave us 90 degrees, because we need to find the height. Well, we can think 30, 60, 90 triangle. If we do so, we know that CD is 6, and across from our 30, that would be our S, if you recall back to our 30, 60, 90 triangle. And across from 60 is S square roots of 3. So you know your height is 6 square roots of 3. So to find the area of your triangle, it's 1/2 your base times your height, which is 6 square roots of 3. And that will give you 36 square roots of 3. Well, now we simply need to subtract these two amounts. So we have 24 pi minus our 36 square roots of 3, and that's going to give us about 13.04 inches squared. Try this next one on your own. Now that you've had a moment to try this one on your own, let's try it together. Well, step 1, find the area of... So we have area equals pi times 4 squared, and multiply that by 90 divided by 360, so our piece of our circle. And when we do so, if we do it all together including our pi, we'll have about 12.56. Alright, well, what about the area of our triangle? We have 1/2 our base times our height. Now, unlike in the last one, this is a 90-degree angle, so we already have our base and our height. We don't have to find one of them. So, 1/2 4 times 4 is 8. So we have 12.56 minus 8, which gives you 4.56 meters squared. Let's look at one more formula. Arc length is the distance along an arc measured in linear units. Very similar to when we were looking at the sector area, only this time, because it's a piece of the arc, you're going to use a piece of your circumference formula. So if your circumference is 2 pi r, you want a piece of that. So we have 2 times pi times your radius, which is your circumference, and then that piece that you were looking for. So let's try it. Find each arc length. So we have 2 times pi times your radius times the piece of the arc that you're looking for. So 90 divided by 360. And when you do so, you get that this is 5 pi, which is about 15.71 feet. Try this next one on your own. An arc with measure 35 degrees and a circle with radius 3. Now that you've had a moment to try it on your own, let's try it together. So we have 2 pi r, so 2 times pi times 3, times the piece of the circle we're looking for, so 35 divided by 360. When we do so, you end up with about 1.83 inches. And that concludes our video on sector area and arc length.